Hi guys, and welcome to another tutorial in Explain Mobile. Today I have the Boeing 737-800, and the Boeing 737-800 is the most popularly used commercial aircraft. It is also the most popular variant of the Boeing 737NG. In this tutorial, I'm going to show you how to start up the aircraft with all the systems down, a procedure called cold and dark startup process. Normally, when pilots come into a cabin, everything else is powered up, and they will simply come and do the following procedures that are required to start up the aircraft for takeoff. But the cold and dark startup procedure is done by a maintenance crew, and this is what we're going to do in this tutorial until we leave the aircraft in a state where it is ready to fly. Okay. So the first thing, I'm going to grab my checklist, and the first thing on it says that we must check that the parking brake is set. The parking brake is down here. Parking brake is set. And then the next thing is that battery master switch must come on. It's enclosed in a guard switch. Flip it open and bring it down. With that having been done, the next thing I need to do is do a couple of tests from the overhead panel. I'll come down here just under the flight data recorders, and I have store warning tests. So we're going to test that our store warning is working by pressing the switches number 1 and number 2. Number 1 is working and number 2 is good. Then next thing, I'm just going to make sure that the oxygen guard switches are closed, and then ECC guard switches are closed, which they are, and then the ALT guard is also closed. Then I'm going to come down here below the mode control panel, and I'm going to test all my warning lights to make sure there's a fault with the aircraft. All the warning lights are working. So there we go. Right below here we have all warning lights illuminated inside the aircraft. If I go to the overhead panel, we should see the same amount of information. All the warning lights on the overhead panel are illuminated, and as well on the after overhead panel. So with that confirmed, I'm going to bring this down. Alright, I'm going to bring it down, and then we're going to test the autopilot and FMC and auto throttle to make sure that also the warning systems are working, which they are. I'm going to flip the switch up and bring it to the normal position. Then we're going to test the engine fire warning system. We're going to test the engine fire detection system first, and there we go. We have the amber indication on fault and APU in operation, and then we're going to flip it to the right to test for engine fire. Well, there we go. We got the fire extinguishers illuminated, engine 1, engine 2 and APU. So we're going to press the master caution and cut the bell by pressing the fire warning. Alright, then I'm going to come back here, and I'm going to switch off the test switch. Next thing is, I'm going to test the aft and forward cargo fire warning test, and there we go. Detection fault in forward and aft indicated in red, and you turn it off by pressing the master caution on the glass shield. Then next thing I need to test is my oxygen bottle store. Next to engine number 2, fire extinguisher. Just flip the test switch to the right, and 3 green must be indicated, and flip it back to normal position. Alright, test confirmed. Then next thing, I need to turn on the left. Next thing I need to do is turn on the standby power. And then I'll just make sure on the electrical panel we have standby power established. We have 99 volts AC, we have 24 DC voltage, and CPS frequency is 398. Now, one thing I must tell you though is that the battery on the aircraft doesn't last long, so it needs another source of electrical power. Either we're going to establish the ground power, but in my case I'm going to use the auxiliary power unit. So we're going to start the auxiliary power unit. First thing I need to do is feed it with fuel from the left and right overhead panel. The left and right fuel pumps must be on, and then we're going to turn on the APU to the start position. Now an APU is a device that's like a little jet engine located in the back of an aircraft. Its main purpose is to provide supplementary electrical power through an APU generator, and it's also used to provide airflow for engine start. Now notice we have a blue light that says APU gen off bus. I'm going to flip down the switches to bring the APU generators on bus. Now we have APU generators on bus, so I'm going to select source of electrical power to the APU generator, and there we go. Now next thing I need to make sure is that the position lights are on and logo light is on, and then I need to make sure that emergency light guard switch is closed, and then passenger fasten seatbelt sign is in the on position, and then PEG switches must be set to auto and high. They're not modeled, but of which they are in that position anyway. And then I need to set my flight management computer. The flight management computer, or the FMS, is down here, located next to the lower display unit. This is where we program our flight route. So first thing I'm going to do is select initial reference, and then I'm going to go to the status page, and it will show me that our navigation data from World of Explain and active database and information that's with regard to Explain. And then I'll press the next button which says route, and then we are going to program our route. Well, if you look already, I have an active flight plan for Papa Hotel November Lima, and destination is Papa Hotel November Yankee, and our flight number is Qantas 13. Now I'm going to go to departure and arrivals, and I'm going to select runway 4 left is our departure, and then I'm going to select Palais 2 as our standard instrument departure. A standard instrument departure is a programmed flight route that allows you to depart an airport until you join your first waypoint on your flight route. So I'm going to select Palais as our standard instrument departure, and then I'm also going to select transition altitude, which is Lima November Yankee. Transition altitude is the altitude when aircraft has transitioned to flight levels. In other words, once you pass that region, you're no longer talking of altitude in terms of feet, you're now talking of altitude in terms of flight levels. Now I've executed that, so I can go to my legs page. So we're going to depart Papa Hotel November Yankee on runway 4 left. Then we have vectors on a heading of 42 degrees. In order to avoid them, I am just going to my first waypoint. So I'm going to select it as Palais, and then select it where the vectors are. And there we go. I'm going to execute that. So as we depart runway 4 left on a heading of 271 degrees, we're going to go to Palais, which is on a heading of 113 degrees, 24 nautical miles away. Then after that we're going to Roshi, which is on a heading of 112 degrees, 21 nautical miles away. Then we're going to go to Lima November Yankee on a heading of 112 degrees, which is 19 nautical miles away. Now I can also select information like airspeed that I want to maintain and the altitude that I want to be. Now for example, when I'm passing through Rocher, I could select that I want a speed of 250 knots when I reach an altitude of 6,000 feet. And then I'll just select that to Rocher. And then at Lima November Yankee, I want 250 knots at 9,000 feet. Then I'm going to press the next page. I have a discontinuity. Now the way to deal with the discontinuity is just to press the waypoint below it into the scratch pad. In this case it's doofdy, then I'll line select it on the discontinuity. And there you have it, then you can execute that. So here I'm going to select 250 knots at 12,000 feet. Then I'm going to select 300 knots at 18,000, which happens to be our transition altitude. Then after that, I'm simply going to select 300 knots again at flight level 20. And then I'm going to select 320 knots at flight level 260, which will be my final cruising altitude. Alright, for now I'll go back to the first page and then I'll leave our legs page here. Next thing I'm just going to do is look through our climb. We have speed and altitude limits at 250 knots below 10,000 feet. It's the international speed restriction. And then my cruise speed, well, I've selected 320 knots. So I'm going to select it here. And then I'm going to my destination. Well, we will set up our destination as we approach into our destination airport. And then another thing is just that I'm also going to show you our holding chart. Our holding pattern is a fixed entry at Grammy, and if you're interested in this information you can just check it out through the flight management computer. Then our navigation radios, I want to set up my navigation radio 1 for an ILS approach into Papa Hotel November Yankee. So I'll just bring up my flight route, my map, and then I'll zoom in on Papa Hotel November Yankee to check the ILS frequency. Now an ILS is represented by an arrow that points into a runway. ILS stands for Instrument Landing Approach. It's used when you're doing low visibility, when you're doing a landing in low visibility. The frequency is 111.10, so I'm going to select that on my navigation radio. So I'm going to select 111 decimal 10. Alright, so that's it for my flight management computer. I'm just going to leave it on the legs page, and my second FMS on the right, I'm going to leave it on the radio page. Alright, FMS is set. Transponder must be set. The transponder is located here. A transponder is a device that allows air traffic control to identify you by a certain code called a squawk. So you enter it into your transponder and air traffic control will be able to identify you. But in this case we don't have air traffic control online, so it's not necessary to set it up. And then next thing we're going to come here on a section called a mode control panel. The mode control panel is where the autopilot system is located, and other automation systems of the aircraft as well. So the first thing I'm required is to set up my airspeed. Now here I'll set up an airspeed called V2. V2 is your initial climb speed. So mine, I'm going to set it to 180 knots, which is my initial climb speed. Now speaking of climb speeds, there's three specifically during a takeoff. You have V1, which is your decision speed. In other words, the speed at which once an aircraft goes beyond, pilots are no longer allowed to abort a takeoff. Then you have VR, which is your rotation speed, and then you have V2. V2 is the speed at which you can safely climb with one engine failed. Mine is set to 180, and my rotation speed will be 150 knots pertaining to my weight. I currently have a weight of 72,000 kilograms. Next thing, I need to set up my heading in the heading window. So my runway heading is 80 degrees. Heading is the direction in which the nose of an aircraft is pointing. Then I need to set up my initial altitude. I have the altitude window, and my initial altitude will be 12,000 feet. Actually 15,000 feet, sorry. There we go, 15,000 feet is set. Then I'm also going to set that up on the overhead panel right here. So there we go, 15,000 feet is set, and I'm also going to set my landing altitude, which is 1,300 feet. Alright, with that being said, I'm going to explain more about the mode control panel. The autopilot systems are located on the right side, and the Boeing 737 has 4 autopilot systems. Now if you look in a little bit closer, the first 2 on the top are written A and B, which stands for autopilot alpha and autopilot bravo. Then below them is 2 autopilots written CWS in the center. That stands for control wheel steering autopilot. It's an autopilot that allows you to control your pitch when it is engaged. Now the next thing we're going to do is set up the yaw damper. The yaw damper is located on the overhead panel, so I'm going to turn it on. And then the next thing we need to turn on, window heat. The window heat is also located here at the back of the overhead panel. Window heat is on, and then flight altitude is set, landing altitude is set, and flight directives must be on. The flight directives are located on the mode control panel, so we're going to press them on, and then you can check it on your primary flight display with an FD on top of your artificial horizon indicator. The flight director is an automation system that coordinates the turning of an aircraft when the autopilot is on. It commands the autopilot on how to control the aircraft during a coordinated turn. It is also represented by a purple bar that is indicated on our artificial horizon indicator, and when the aircraft is flying, it will show the position that the aircraft nose must be pitched and the lateral motion of the aircraft that is required as well. With that said, I'm going to go to the flight directives are on. LNAV and VNAV is required. I'm not going to be using LNAV and VNAV initially. I am going to be using vertical speed, and we're going to do a vertical speed of 3,000 feet per minute during our climb. Alright, that is set, and then minimum reference is set on our barometer. Now we're going to be using this device here called a radio barometer. Minimums is the lowest altitude at which a pilot can descend to, and if they don't see the runway, they will have to abort the landing. That's because you will be within close proximity to the ground. So I'm going to set minimums for my landing elevation at 300 feet above ground, or 300 feet AGL. Because the landing altitude is at 1,300 feet, I'm going to set minimums at 1,500 feet. Now our minimums is set to radio, which means that we have an annunciation, audible voice in the cockpit, which will announce minimums as we pass our lowest descent altitude. Alright, so I'm going to bring it down to 1,500. Alright, just slightly higher there. Alright, that is set. I'm also going to take flight path vector and meters. Meters allows my altitude tape to also represent altitude in terms of meters. As you can see, it's written 7 meters, feet above ground. And then we're going to set auto brake to rejected takeoff. And then COM radios are set. The COM radios are down here. So you can select frequencies for COM radios, but we don't have a TC as I mentioned, so it's unnecessary. And doors are closed, they're not modeled in this flight sim. And that is done. So another thing that I just needed to explain here is that we have weather radar modes on our AFIS mode control panel that you're looking at right away. So we have weather, and we have star for standard terminal arrival, and we have waypoint, and we have our airport, and then we have data, and then we have position, and we have terrain and traffic. So the traffic radar must be indicated. As you can see, it is on our navigation display. Alright, the next checklist is the before start checklist. Now it says that auto throttle must be armed. An auto throttle is a system that automatically regulates the engine thrust when a given airspeed is entered on the speed window. As you can see, we entered the speed of 180. Once I arm the auto throttle system, and during a takeoff, the aircraft will be able to maintain that speed. Then the next thing I need to select is left, right and C fuel pumps on the overhead panel. And we also need to select aft and forward fuel pumps. In fact, all the fuel pumps must come on. With the fuel pumps having been set, I need to turn on the electro-hydraulic pumps. So I need to come on the overhead panel, and electro-hydraulic pumps and engine hydraulic systems must be on. And then anti-collision lights must be on. So I'm going to come down here. Anti-collision light is on, and parking brake is set. We did that, and ground equipment I removed. So I need to check through the window that there's no ground equipment around us. I look to the left first, and then I'm going to look to the right. Yes, we don't have ground equipment. And then engine area is clear. I assume that air traffic control. I assume that ground crewmen have cleared up engine area. So engine area is cleared. And that's it for the before start checklist. The next checklist that we need to look at is the engine start checklist. Now, in order for us to start our engine, as I mentioned, we require the auxiliary power unit. So the auxiliary power unit is on already. So what I need to do is turn on the auxiliary power unit bleed system. And you can see the duct pressure is rising. Now the way this system works is that it provides bleed air system to the engine to spin the engine compressors. Now as the compressor revolution rises, we'll then introduce fuel into the engine. The compressor revolution is indicated what is called N2, which is represented on which is shown here on the lower display unit as N2, as you can see it. Now once it reaches 20%, we then introduce fuel with the engine cutoff fuel switches, and then we'll then monitor EGT, which is engine gas exhaust temperature, and N1. N1 is the rotation of the fan, and it is also the percentage of engine thrust. We'll also check our fuel quantity. We have 10.3 tons of fuel in total, and we have 6.34 tons in the center tank, and 1.98 in the left tank, and 1.97 in the right tank. The right tank is less fuel. Why? Because it's providing fuel for the auxiliary power unit. Alright, in order to start our engine, we come on the overhead panel. to the engine switches. So I'm going to start with engine number 1 by flipping the engine start switch to the ground position. And then I'm going to monitor rise in N2. There is 20%, so I'm going to introduce fuel. And then I'm going to monitor EGT and N1. At the same time, you can also see that the warning lights in engine 1 area have extinguished. Engine warning lights have extinguished, EGT is stable and N1 is stable. So I'm going to start engine number 2 by doing the same procedure, flipping the engine start switch to the ground position. And then we'll monitor rise in N2. At 20% we introduce fuel. There we go, 20%, and we introduce fuel, and then we just monitor EGT and N1. And at the same time you can see that warning annunciation for engine number 2 are disappearing. Alright. So both engines have been started. Now the next thing I'm just going to do is I'm going to select my my display to the map mode. Alright. And that is done. Then the next thing I'm going to go on the overhead. There we are. And then I'm going to bring engine 1 and 2 generators on bus. So there we go. With the engine generators on bus, it means I no longer need the auxiliary power unit generator. So I'm going to trim electrical power to either engine generator 1 or engine generator number 2. In this case, I'm just going to select engine generator 2, and it's providing us with 112 volts AC, 28 volts DC, and our CPS frequency is 406. So I'm going to switch off APU generators. Then I'm going to turn on engine bleed systems to provide air conditioning airflow. Then that means I don't need APU bleed system anymore. So I'm going to switch off the auxiliary power unit. With the APU being switched off, I'm now going to select the engine start switches to continuous ignition. And then flaps must be set for takeoff. We're going to depart with 15 degrees flaps. The flap lever is located next to the throttle quadrant, so I'm going to select it to 15 degrees, and then I'll just check it from here, just under the mode control panel. You can see it says flaps in transition. Then elevator trim is set for takeoff. I'm going to set elevator trim to 8 to 9%. 10% actually. Alright, elevator trim is set. Your flaps are extended. And then flight controls must be checked. So the next thing I'm going to do is check the flight controls. There we go. Full left, full right, full pitch, and full pitch over. Flight controls are checked. And then we'll press the annunciation on the master caution for recall 737-800. It's done. And then we can switch off the lower display unit. To switch off the lower display unit, you can just come down here and turn it off with these little switches that are just under the primary flight display. So you can adjust the level of brightness of these instruments. Still not the correct one. These little switches adjust the level of brightness for each and every display. The lower display, as you can see, it's written there, and we can switch it off if we want, but in my case I'm going to leave it on. Notice my navigation display has dimmed. That's because I've put it to low brightness. Alright, now the next checklist is the taxi checklist, which we'll do when we are to the runway. So that's it for our cold and dark startup. We have the Boeing 737-800 ready for taxi. Thank you guys for watching, and I'll see you as I do my